Good morning, children. Today we will see the theorem of cyclic quadrilateral. Okay, and the statement of the theorem is if two points on a given line subtend equal angles at two distinct points, which lie on the same side of of the line, then the 4 points are concyclic. Then 4 points are concyclic. The meaning of this theorem is what is the meaning of this theorem? The theorem's meaning is if these 2 points are there, if these 2 points are there, and if 2 points on a given line. So first of all we will draw the figure. This is a figure. This suppose line's name we will give it is as a P and this is Q. So these points, 2 points are there on a given line. So this is the points on given line. Suppose L is there. Subtend equal angle with the 2 distinct points which lie on the same side of line. So this is the line, same side of line. Suppose here I took 1 point and here I will take 1 point. This is R and this is S. Okay. Now what I will do? I will join these points. I will join these 2 points. And this measure is x degree. And I will draw here one more angle and its measure is also x degree. So that if such a situation there, then these PQRS are a concyclic. Concyclic means they lie on the same circle. So that we have to prove. They lie on the same circle. So first of all, we will see this is actually indirect proof. This is indirect proof. So whatever is given that we have to take as a false, and we have to show that whatever is given is we have to take as a false, and then we have to take another statements which is false, and that we have to prove that this is false, and the conditions are whatever we are considering it is wrong. So the condition which is given in the theorem, it is correct. So for that, first of all we will draw the circle. So I will draw here 2 circles. If this PQRS, as you know that circle is passing from the 3 non-collinear points. This is suppose PQS. From these 3 points the circle is passing, and from point R the circle is not passing. These 2 conditions we have to take. If R is not lies on the circle, then there are 2 possibilities. First possibility is suppose this is my circle. This is the first possibility, and that is second. What I told you, if these 2 points, if this point R, as you know that the circle is passing from a 3 non-collinear point. So this is P, this is Q, and this is S. From these 3 points circle is passing. From these 3 points circle is passing, and circle is not passing from the point R. That we have to consider. So if circle is not passing from the R, then this R point is there. It may be exterior of the circle. Okay, it may be exterior of the circle. Here also same figure PQ, and here it is S. And second condition is the circle, this point R is there, it is outside the circle, or this R is there, it is lies inside the circle. There are two conditions. This point R is there, it is outside the circle, or point R is there which is inside the circle. Okay, so according to information, if 2 points on a given line subtend equal angles, means these 2 points are there, they subtend equal angle with 2 points which are on one side of a line, then the 4 points, which took 4 points P, Q, R, S are on a concyclic. Actually it is indirect proof. So we have to, this is indirect. So it is a true, but we have to take this statement as a false, and this point R is not lying on the circle. If it is not lying on the circle, it may be outside the circle or it may be inside the circle. Okay, then now we will join this R point with Q and this Q. Okay, as in given, this R is what? This measure is same. Now here also what we will do? This R we will join with the Q. This is point, this is angle X. This we will extend, and here we draw the another point we will take here T, and which is on the circle. Okay, this is point T which is on the circle, and that also what we will do? We will join it with the circle. That is our, okay, this is point T. Now whatever we had done in the figure, that we will write at first. Okay, so first we will write the given. What we will write? Given. So point, here write points S and R lie on the same side, lie on the same side of the line AD, of the line, this is line PQ. In any figure you see, this is the PQ side, PQ line is there, and on its above side, means on the above the line S and R points are there. These S and R lies. Okay, so that is our given. What we have to prove? We have to prove that actually it is big theorem, so I am using the space which is given here, which is present, which is PROVB. Okay, what we have to prove? The points P, Q, R, S are concyclic. Points P, Q, R, S are concyclic. Okay, these are the concyclic, and thus PQRS is a cyclic. Okay, so this theorem can be proved indirect method. Here write quadrilateral PQRS is cyclic or concyclic. So we have to prove this cyclic. This theorem can be proved by indirect method. Okay, so this is the indirect method we already. So there are that we know that. Now we will see the proof of this. This is the figure, these are the figures. According to it, what we will write? We will write here proof. So there is one and only one circle passed, where that we know that there is one and only one circle that passes through three non-collinear points. Non-collinear points that we know. Okay, that we know. Then then a circle passes through point PQS. Therefore we will take, therefore a circle passes through points, passes through point P, S and Q. P, S and Q. Okay, and let us assume that fourth point, which is the fourth point, that is the R. So this circle is passing from P, Q and S point, but it is not passing from point R. Okay, so therefore fourth point R Fourth point, R lies in the interior. Fourth point, R lies in the interior or exterior of the circle. Interior or in exterior of the circle. Okay, so I shown you here this point is interior of the circle and here it is exterior of the circle. So let us assume that what we have to assume that point R lies, first condition, that point R lies in the exterior of the circle, lies in the exterior of the circle. Okay, this is the first condition. Okay, now here if it lies in the exterior of the circle, let the sec PR intersect this, let the sec here, right, let next line we will use, let the sec PR intersect the circle, at point T. Okay, here it intersect for both the statements. What happens? This intersect at point T, and draw sec QT. We drawn here already. So draw seg QT. This QT we had drawn here, QT. Okay, now what I told you that this is the point. At that point what happens? PR is there, it is intersect to the T. Okay, now what we have to do, as we know that here what they gave us, given inside these two angles given inside one point, I forgot to write, that is here we have to write angle PSQ is congruent to angle PRQ. Okay, PRQ angle equal in measure, so equal written, no, then also okay, equal to angle PRQ. If they are equal, they are congruent to each other. So here write but angle PSQ is equal to angle PRQ. If they are equal, means they are congruent also, and that's why we have to give here congruent sign, and it is given. Okay, it is given, means x is, and this measure is x, but this is the angle it lies on the circle and same endpoints are there, so this angle's measure is also same, that's why this angle's measure is also we have to take as a x, or any you take. Here right, angle PSQ is congruent to angle PTQ, and reason is the angles inscribed in the same arc. Okay, these two are the angles which are inscribed in the same arc, because the arc, which arc they intercept, that is inscribed, that is PQ. So x is this PSQ is congruent to PTQ also, and this PSQ is congruent to PRS also from this. So this PSQ and PSQ is same, therefore from 1 and 2 you write here give the statement 1, and here it is the statement second. So this LHS is equal, so RHS is also equal, therefore angle PRQ is congruent to angle PTQ. Okay, that we should. Now here write from 1 and 2. Okay, now these two are congruent. These from 1 and 2 they are congruent, and that is our statement number 3. But here what we have to write, but this PTQ is there, PTQ. This PTQ angle is exterior angle for QTR, and as we all knows that exterior angle is equal to sum of remote interior angles. So angle PTQ is equal to TRQ plus TQR, these two angles sum. But here we are showing these two are the equal in measure, so whatever we said that it is wrong. So that we will write here. But angle PTQ is exterior angle of triangle PTQ. This triangle TRQ, TRTQ or TRQ. Okay, now and as according to exterior angles theorem, okay, according to exterior angle theorem, PTQ is greater than TRQ also and TQR also. So here write angle PTQ is exterior angle according to this theorem, exterior angle theorem, PTQ is greater than TRQ. PTQ is greater than TRQ. Okay, so TRQ, otherwise PRQ you take. TRQ or PRQ. So this is what we said that, and this is the exterior angles theorem. Exterior angle theorem. Okay, but here PT is that we will extend only PTQ is greater than, instead of writing TRQ, here write which is PRQ, and that is our statement number 4, P-T-R, and this is statement number 4. Now in third statement inside, what we are saying that, in third statement sir, we are saying that PRQ is congruent to PTQ. PRQ is congruent to PTQ, and in fourth statement we are saying that this PTQ is there, it is greater than PRQ. Here we are saying equal measure, and here we are saying it is greater. So these two statements are there, these are contradicts. So this that third and fourth, these two statements are there, they contradict each other. Okay, these contradicts, and what happens, this contradicts, therefore our assumption is what? It is false. Our assumption is false. That is the first that what we had here we had taken, no? So this is the first assumption. We shown that it is false, means point R does not lie on the exterior of the circle. Exterior of the circle, it must be on the circle. It must be on the circle. So our assumption is false, and here write therefore point R not lies in the exterior of the exterior of the circle. This point R is there, it will not lie exterior of the circle. Okay, and here we have to write exterior of the circle. Now second condition we will take here. This is the second condition. What is our second state condition? Point R is there, it lies inside the circle. So here we will take, let us assume that point R lies interior of the circle. R lies interior of the circle. This point R is there, it lies interior of the circle, and same thing we have to write here, that is, if this is interior, this is the first and this is second one, if it lies interior of the circle, then what is the first of all, given inside what they told you, this PSQ is congruent to PRQ. Here it is written, angle PSQ is congruent to angle PRQ, and it is given. But we are saying that this PTQ is also congruent to PSQ. Angle PTQ is also congruent to angle PSQ, and reason is this only, angles inscribed in same arc. Angles inscribed in same arc. Okay, this is our which one, fourth over fifth statement, and this is our sixth statement. Okay, now what we have to do here, this is our this is the figure we will take and we will solve the proof. So this two, for fifth inside what we are saying, this angle PSQ is congruent to PRQ, and third is next inside, sixth inside we are saying that PSQ is also congruent to PRQ. So from 1 and 2, this PSQ is common, PRQ is congruent to PTQ, that we will write here. Okay, from 1 and 2 here, right? From 1 and 2 not, it is 5 and 6. From 5th and 6th, from 5th and 6th, we say that what angle, which angle, this here, angle PSQ is congruent to, PSQ is congruent to what we said, that PRQ. This PSQ is congruent to what we said, that PTQ. So angle here, this PRQ and RTQ, angle PRQ is congruent to angle PTQ. Okay, these two angles are congruent. Same thing we have to say that, but angle PRQ is exterior angle for PTQ. So this is our which statement number? Statement number 7. So here, right, angle PQR, this PRQ, sorry, this angle, but right here, but angle PRQ is exterior angle, PRQ is exterior angle of triangle exterior angle. You see here in the figure PRQ, this PRQ is there, it is exterior angle, PRQ is exterior angle of triangle RQT, triangle RQT. Okay, and as we all know that the exterior angle is greater than the sum of any remote interior angle. So what we have to write, therefore here, right, it is exterior angle, therefore this PRQ angle PRQ is greater than PRTQ, angle RTQ. Okay, that is our which statement number 8. Okay, this angle is greater than this. In first 7th statement we are saying that this PRQ is congruent to PTQ. Okay, here we are saying that. Okay, these are congruent to each other. So in 6th, 7th statement we are saying that this angle is greater than this angle. One statement means we are saying this congruent, and one statement means we are saying this angle is greater than this one. So whatever we are saying here, it is confusing, it means it is false. So just we will increase this angle only. Therefore angle PRQ is greater than, instead of writing RTQ you write here PTQ. PQ. Okay, and reason is that P dash R dash T. Okay, so this is the betweenness, and here we are saying, so here statement which is this, instead of giving 8 here we will give it here to 8. Then the statement number 7 and 8, these are contradicts. Once we are saying they are congruent to each other, once we are saying well, it is greater than PTQ. So these two statements are there, they contradict each other here, right? The statement 7 and 8 contradict each other, okay, and they contradict each other. Okay, therefore point PO, therefore this point R does not lie in the interior of the circle. Okay, so first what we shown that this point is there, it does not lie in exterior of the circle. Here in first statement inside we said that this point does not lie in the exterior of the circle. Here we said that this point R is there, it does not lie what, interior of the circle. So which is the last that condition left, it does not lie exterior, interior. So where it will lie? It will lie on the circle. So here, right, therefore point R lies on the circle. Therefore, point R lies on the circle. Okay, this point lies on the circle means what? This P, Q, R, S are concyclic. Therefore, points interior of the circle is false. Is false right here. Okay, therefore point R lies on the circle, and therefore which points P, Q, R, S are concyclic. Concyclic means from these 4 points what the circle is passing. Okay, these are the concyclic points. In this way we prove that these points are there, which if this the line is there, if these lines 2 points on the given line, subtend equal angle, these are the S and R. If there is subtend equal angles at 2 distinct points which lie on the same side, means PQ's another side, one side is this above side R and S point are there, and if it is there, then these 4 points are concyclic, means from PQRS from PQRS a circle is passing. Okay, so once we will just revive this, what we had done it here, we have to show that if these 2 points are there, S and R, they lies, this line is above one side and they have the equal angle, means PSQ and PRQ having the equal measure, then these points are concyclic. Actually it is indirect proof, so we have to assume that whatever is the correct, we have to assume it is false. So what is correct? This point R is not lying on the circle. It is exterior of the circle or it may be interior of the circle. So first condition inside we took here, R is there, it is exterior of the circle, and for that what we have to show that this, as you know that this angle S is congruent to R. It is already given in the given. Then here if these are equal, then second inside what we have to take, PSQ and PTQ, they are also equal or congruent. Reason behind it is the angles inscribed in the same arc. So this angle S, this angle T and this angle R must be congruent. Okay, but this angle PTQ is there, it is exterior of this triangle, exterior angle of this triangle, and as we all know that exterior angle is always greater than this 2 remote interior angles, means it is greater than TRQ also and it is greater than TQR also. Okay, now and here this statement what we, once we are saying they are congruent to each other, these 2 angles are congruent to each other, and once we are saying this angle is there, it is greater than this angle, so our assumption is false, and where, so the point R does not lie exterior of the circle, that we prove here. Next, second inside what we have to assume that this point R is there, it lie interior of the circle. So interior of the circle, same thing we have to do that S is congruent to, angle S is congruent to T, already given that S and R are congruent to each other, it is given, and these angles are there, means S angle and T angle, they inscribe the same arc, that's why these 2 angles are congruent to each other. Okay, here we shown that. Then afterwards what we have to do, that is these 2 angles, which these two angles are congruent to each other, and these 2 are congruent to each other, it is given. Okay, now what we have to do here for this RTQ, this point angle PRQ is there, it is exterior angle, and if it is exterior angle, it is greater than RTQ and RQT both. So here it is exterior, so it is greater than RTQ. Okay, so here we wrote here it is greater than RTQ. One statement inside what we are saying, here we are saying PTQ and PSQ are, this PTQ and PRQ, they are congruent to each other. Here second inside what we are saying, PRQ is greater than RTQ. So whatever we are saying, it contradicts each other, means they are not matches each other, it contradicts each other. Therefore what happens, our assumption is false, that is point R lies inside interior of the circle is wrong, and that's why what is correct. So for both the conditions we can get, what happens, false. It doesn't lie exterior also, it doesn't lie interior of the circle. So the last only assumption left, that is it lies on the circle, and so we have to write it as the point R lies on the circle, and if point R lies on the circle, then this PQRS is a concyclic. Okay, so today we saw this only theorem, it is big one and it is indirect proof, and indirect proofs are little bit understanding is is little bit difficult, so all of you practice it properly, this theorem, okay, and that next part of the lesson we will see in our next lecture. Okay, thank you.